as promised, quickly the video on how to use oxidation numbers in redox. Alright, so you have the rules. You need to know that everything in group 1 will have a +1 oxidation number, group 2, 2, then we jump all the way to the halogens that are normally -1, and then there are some exceptions, but you have them all and you can just learn those rules that you have been given. And then also the polyatomic ions, the compound ions, you need to know that SO4 is 2-. We've said this so many times before. You cannot do chemistry if you do not know your polyatomic ions, your compound ions. So you need to know that SO4 is -2. And why I put this one in here is that you can see that some substances like iron can have different oxidation states. So you know already that from the stock notation here, we can see that this is going to be Fe2+ and this is going to be Fe3+. But if they didn't tell you that, if you only had these two formulae, then you can get that oxidation number by looking at the rest of the molecule. So you have FeSO4. And if you know that SO4, try and keep your compound ions, if they don't change into something else, you can keep them together, because remember, that's why they are. They live together, like living together like that. And you know SO4 is going to be 2-, because you've learned it so many times. And because SO4 is 2-, it means that Fe is going to be 2+. Because if we are looking at this whole thing here, it didn't have a charge, and therefore now that will give me 0, a +2 -2 will give me a 0. If something does have a charge, let me just put that in here in case. You have SO4 2-, remember that is our iron. Let's say they asked you for the sulfate, sulfide. Let me get it right. If it's an S ion, it's going to be a sulfide ion, remember that. Alright, so if you're looking at oxygen here, you know that oxygen is -2, so there's oxygen is -2, but we don't only have one, we've actually got 4 of them. So we've got 4 -2s, which means that we end up with a -8. But this time we're not aiming for 0, we're aiming for a 2-, so we need to end up with -2. Now you need to think, alright, if I have to get to -2, I have -8, what must the positive be here? And that will then show you easy maths. If it's +6 -8, then we're going to end up with a -2, so the oxidation number of sulfur, or the oxidation state of that S there, will be +6. So this you must be able to do. And I know I got sidetracked there, you know I'm a bit ADD, but yeah. This one is again easy because we know that Cl is a halogen, and that's going to means that it's going to be -1. But you can see there again, it's not just one of them. We've got 3 of those, which means that we've got for the Cl3 here, we've got -3, which means that the Fe, the positive one here in the front, must be +3, because in that case there was no charge. So we need to end up with a 0 again. Alright, so that's just plain and simple oxidation numbers. You need to be able to assign them according to the rules and work out something's oxidation number within a compound. But then we have to now use these oxidation numbers in oxidation and reduction reaction so that it can help us with a redox reaction. So let's do that. So what I do first is I would look at this and say, okay, the easiest thing to remember is that if there's nothing bonded to that substance, if it's just the element, then we know it's going to be 0. So I assign those first. So I would go and say, that is just an element, that is just an element. So you put the zeros there. Then you follow your rules and you know K, potassium, is in group 1, so K is going to be +1. I is a halogen, so that's going to be -1. I'm just writing it at the bottom so that I can have some space there. This K is now going to be still +1, and the Cl is going to be -1. Okay, so that's relatively easy. Now my next step is to see what has stayed the same and what has changed. So go and find something that stayed exactly the same. And if you look carefully at it, you'll see that this K here was +1 and it is still +1. And now that is kind of important because we could ask you that is our spectator ion, because it's just looking what's going on, but it's not actually taking part in this reaction as the definition tells us. Now let's see. I would go, even if the question doesn't ask you to do it, I would go and put these arrows in because it makes life easy for you. If you're looking at I went from, I should have written them both at the bottom, but anyway, it's still going to work. If you're looking at it's going to go from -1 to 0. So the number has actually increased, going from -1 to 0. So you can think about it, the number increasing, which means it's oxidation. Or if this was negative and now it's 0, it had to lose something that's negative. So you can see that this is a loss of electrons, and you have learned the whole oil rig thing. Oxidation is a loss of electrons. So you know already that this is your oxidation half reaction. And what I would immediately go and do then and say, if this is my oxidation half reaction, the substance that I started with is going to be my reducing agent. So the reducing agent gets oxidized, remember. Now I'm going to go to my other substance here, the Cl, or the chlorine went into chloride. So it went from 0 to -1. So that number went down, which shows us that it's reduction. And if you look at the electrons, the electron transfer, it is now more negative. If it's more negative, it means it was a gain of electrons. And again, oil rig reduction is gain. And immediately, so that you don't have to worry about it when the questions comes at you, if you do everything here, the questions goes very fast. So here we have the reduction half reaction, so you know that this substance again that you started with is then going to be my oxidizing agent. And now it's easy. You can go to the table, or you can just use this to write your oxidation and reduction half reaction. This is going to be my oxidation half reaction. I'm going to write them quickly. So oxidation is the I. So I know I start with I minus. If you don't want to think here, just go to the table and find the reaction that starts with I minus, and you will see that it's on the right hand side. And your table, let me just show you on the table quickly. Your table even tells you here that I is here on the right hand side. Ooh, where is it? Sometimes your biggest job is to find them. There's I. So it can only go this way, but the table even tells you here that it's the reducing agent. So you can double check. Did we say? Yeah, we said that was the reducing agent. So that's perfect. So you can copy it straight from the table and say I minus forms I2. But, what am I doing? 2. And we need 2 of them, but you don't have to worry about the balancing because the table gives it to you anyway. That's going to be my oxidation half reaction, reduction half reaction. I'm just going to write quickly as well. That starts with Cl2. So Cl2, and again you can go to your table and just find it there. It's quite at the bottom, the Cl here. So Cl2 can only go towards the right, and you can see that that is a gain of electrons, which is reduction. The table tells you that it's the oxidizing agent. Let's check. Yay, we did say it's the oxidizing agent, so everything is perfectly right. And you can copy this reaction from the table as well, or figure it out. Forms to Cl minus. And this is an easy one to balance because we've got 2 electrons, 2 electrons. So that means we don't have to worry about multiplying anything. Now you're going to put your one-way arrow. Remember, all of them one-way arrows. You're going to say 2I minus, write everything on the left-hand side on the left, plus Cl2 gives us I2 plus 2Cl minus. And that is our net ionic equation. All right, so this is a pretty easy one. But this is important. You can definitely get questions like this. Now, remember the definitions. You can also, they can say in an exam to you, show that this is a redox reaction, or which of the reactions is a redox reaction. So as soon as you see that there's a transfer of electrons, now from where to where did the electrons go? The electrons that went from here, the one that gives off the electrons, that the electrons are here on their own, went from there towards there. So the electrons went from the I minus, which is the iodide ion, get the word right, to chlorine, which is Cl2, which is the element. So if they say name, please remember you cannot write the formula. Don't get caught by that again. If they say name, we want to hear or see iodide and chlorine. All right, now if you get a reaction and we don't give you the products, and you need to decide what the product is, and we have to say, okay, we're going to write an oxidation half reaction, reduction half reaction, and a net ionic reaction for this. Then we're going to say, fine, permanganate ions react spontaneously with iodide ions. Now, here it's given. We don't have to give you this. You need to know permanganate ions is MnO4 minus, and you need to know that iodide ions is I minus. That was just being nice. Now, when you see this, you go and find them on the periodic, not that table, the redox table. Now, let's see if we can find them. As I said, sometimes finding them is our biggest job. We need to find MnO4 and we need to find I minus. Now, go and highlight them on your table. There we've got an MnO4. I don't think there's another one, but do check. Sometimes there's more than one. So there's an MnO4 and there's an I minus. Now the table again helps you. They tell you that this is my reducing agent. So we know already reducing agents are going to get oxidized. And the table tells you that as well, because it can actually only go that way. So you can now go and write down that half reaction there and say that this is going to be oxidation half reaction is going to be 2I minus gives me one-way arrow again, I2 plus 2 electrons. And then you can write your reduction half reaction. So you can see once you found them on the table, you're literally just copying it down. And this is going to be MnO4 minus plus 8H pluses. Now I know they didn't give you H pluses, but the question normally will tell you that it's acidified, but you don't always have to worry about it. If they tell you that it does react, then we can assume that those are there, because it did say react spontaneously. Plus 2 electrons gives us H2. Oh, and there, can you see what I've just done? My eyes just went skew and I'm looking at the wrong reaction. So please make sure that you underline it or something, that this doesn't happen to you. MnO4, 8, see, I copied it totally wrong because I moved my table. So it's plus 8 H pluses plus 5 electrons forms Mn2 plus 4 H2O. And then the rest becomes the same. You can just go and see 2 electrons, oops, 5 electrons. That's not going to work. So you need to now get them to be the same. And we're going to do that, we're going to multiply. We're going to multiply this one by 5. But remember, what you do on the one side, you have to do on the other side, and for every single term. And we're going to multiply this one by 2. You can rewrite them if you want to, but it's actually just a waste of time. And you can also just write times 2 at the end of the reaction. You don't have to do it so many times as I've done it. But now only can we say, fine, now I've got 10 electrons here, 10 electrons here. I put my arrow. I actually like writing them, the arrows underneath each other, because it just becomes neat, makes it easy for them to give you marks, and helps you sort your brain out in exam stress. So there would be then 10 I minuses on this side. There would be 2 plus 2MnO4 minus plus 16H pluses, and here we've got the I2. If you want to, you can even scratch them out, but just be careful if you needed to get marks for this. This is now 5, you can't scratch it out. 5I2 plus on this side we have, oh yeah, I am still right. I don't know why I thought I was going wrong there. Mn2 plus 8H2O. And there is my balanced ionic equation. So you can leave it like that, because if it says ionic equation, then it's already there and you don't have to stress about changing anything. And that is that. Now you can just go and practice this a bit more.